Welcome, dear traveler of thought and time, to a quiet corner of the cosmos, where curiosity floats gently among the stars. Tonight, we invite you to settle in, breathe deeply, and let your mind drift through the soft corridors of history, illuminated by the quiet bravery of creatures who once soared beyond Earth's embrace. This is a story not of rockets and rivalry, but of life, small, fragile, and wondrous, carried into the unknown. Before we begin, we gently ask you to subscribe to this channel, not just to stay connected, but to join a growing constellation of dreamers who seek knowledge wrapped in calm. Your presence here is cherished, and your support helps us continue crafting these tranquil journeys through time and space. Now, as we prepare to lift off into the past, a moment of reflection is needed. This video explores the lives of animals sent into space, a chapter of science that is both fascinating and, at times, sobering. We must acknowledge that many of these missions involved suffering, sacrifice, and ethical complexities. The channel does not condone any form of animal cruelty, nor do we celebrate the pain endured by these creatures. Instead, we offer this story as a gentle tribute, a way to honor their role in shaping our understanding of space, and to reflect on how far we've come in our treatment of all living beings. This video is intended solely for informative and relaxing purposes, a soft-spoken narrative that invites contemplation, not controversy. With that in mind, let us begin. Imagine the silence of space, vast and unyielding, broken only by the hum of instruments and the quiet pulse of life inside a capsule. Long before humans ventured into orbit, animals were chosen to test the boundaries of survival beyond Earth. They were pioneers, not by choice, but by circumstance, sent aloft to answer questions we could not yet ask ourselves. Their stories are woven into the fabric of space exploration, each one a thread of courage, curiosity, and consequence. As we drift through this timeline, you'll meet fruit flies and dogs, monkeys and mice, tortoises and jellyfish, each with their own quiet legacy. Some returned, others did not. All contributed to a deeper understanding of biology, physics, and the resilience of life. So, find a comfortable place to rest. Let your thoughts settle like dust on a lunar surface, and allow this story to unfold gently around you. We'll begin with the earliest experiments, when the idea of sending life into space was still a whisper among scientists, and the stars were distant dreams. Thank you for being here. Let's begin our journey. Let us drift now into the earliest moments of this extraordinary tale, when the idea of sending life beyond Earth was still wrapped in wonder and uncertainty. The year was 1947, and the world was just beginning to recover from the tremors of war. In the quiet corners of scientific laboratories, minds turned upward, toward the stars, wondering not just what lay beyond, but whether life could survive the journey there. The first living beings to venture into space were not mammals, nor birds, but fruit flies, tiny, delicate creatures chosen for their simplicity and biological familiarity. On the 20th of February, 1947, aboard a V-2 rocket launched from White Sands, New Mexico, these flies were gently placed inside a capsule and sent soaring to an altitude of 68 miles, brushing the edge of space. Their mission was simple: to help scientists understand the effects of cosmic radiation on living tissue. The flies returned safely, their tiny bodies carrying answers to questions that had never before been asked. It was a quiet beginning, humble and almost unnoticed, but it marked the start of a new era, one where animals would become the first explorers of the final frontier. As the 1950s unfolded, the race to space intensified. The Cold War cast long shadows over the Earth, and both the United States and the Soviet Union sought to prove their technological prowess. In this climate of urgency and ambition, animals became essential participants in the quest to conquer space. Among the most famous of these pioneers was Laika, a small stray dog found wandering the streets of Moscow. Chosen for her calm demeanor and resilience, Laika was trained for spaceflight, her body gently adapted to the confines of the capsule, her heart monitored for signs of stress. On the 3rd of November, 1957, she was launched aboard Sputnik 2, becoming the first animal to orbit the Earth. Her journey was historic, but also tragic. The technology of the time could not ensure her safe return, and Laika died within hours of launch due to overheating and stress. Her story, though heartbreaking, became a symbol of sacrifice and progress, a reminder of the cost of exploration. In the years that followed, the Soviet Union continued to send dogs into space, refining their methods, improving life support systems, and learning from each mission. Dogs like Belka and Strelka, launched in 1960 aboard Sputnik 5, became the first animals to orbit the Earth and return safely. Their survival marked a turning point, proving that life could endure the rigors of space and come back whole. These missions were not just scientific, they were deeply emotional, filled with hope, fear, and the quiet companionship of creatures who could not understand the journey they were on. Across the ocean, the United States was conducting its own experiments, focusing primarily on primates. Monkeys and chimpanzees, chosen for their biological similarity to humans, were trained to perform tasks, respond to stimuli, and endure the stresses of launch and re-entry. One of the earliest American space travelers was Albert II, a rhesus monkey launched in 1949. He reached an altitude of 83 miles, but tragically died upon impact due to parachute failure. His mission, though brief, provided valuable data and paved the way for future flights. In 1951, a monkey named Yorick became the first to survive a spaceflight, returning safely alongside a group of mice. These small victories built confidence, each mission a step closer to sending humans into orbit. Perhaps the most famous of the American primates was Ham, a chimpanzee trained to perform tasks during flight. On the 31st of January, 1961, Ham was launched aboard a Mercury Redstone rocket, his capsule soaring 157 miles above the Earth. During the flight, he successfully pulled levers in response to lights, proving that trained behavior could be maintained in space. Ham returned safely, his face captured in photographs that would become iconic. He lived for many years after his mission, eventually retiring to a zoo, where visitors could meet the chimp who had once touched the stars. These early experiments were not without controversy. The use of animals in space raised ethical questions that still echo today. Many did not survive, and those who did often endured stress, confinement, and uncertainty. Yet their contributions were profound. They helped scientists understand the effects of weightlessness, radiation, and acceleration. They tested life support systems, guided the design of spacecraft, and ultimately made human spaceflight possible. As we reflect on these pioneers, let us do so with gentleness and gratitude. They were not volunteers, nor heroes in the traditional sense, but they carried the hopes of humanity into the unknown. Their stories remind us of the complexity of progress, the intertwining of wonder and responsibility. In the quiet of space, their presence was a whisper of life, a fragile heartbeat in the vast silence. And so, as we continue our journey, let us carry their memory with care, honoring not just their role in science, but their place in the story of exploration. The stars may be distant, but the path to them was paved by tiny feet, soft fur, and silent courage. Let us drift onward now, into the next chapter, where the diversity of spacefaring animals expands, and the lessons they taught us grow ever deeper. As the stars continued to beckon, the Cold War deepened, casting its long and complex shadow across the globe. In this era of tension and technological ambition, space became not just a frontier of discovery, but a stage for competition. The Soviet Union and the United States, locked in a silent race above the clouds, turned increasingly to animals to test the limits of life beyond Earth. The missions grew more frequent, the species more varied, and the lessons more profound. In the Soviet program, dogs remained central figures, chosen for their size, temperament, and adaptability. These animals were carefully selected and trained, often living in close quarters with scientists who came to know them intimately. The dogs were not just test subjects, they were companions, their personalities documented, their preferences noted. Some liked music, others preferred silence. Some were playful, others solemn. Each one carried a story, a quiet dignity that transcended the wires and monitors surrounding them. Between 1951 and 1966, the Soviet Union sent dozens of dogs into space, refining their techniques with each launch. Missions like those of Veterok and Yugolyok in 1966 pushed boundaries, keeping the dogs in orbit for 22 days, a record that would stand for years. These flights tested endurance, monitored physiological changes, and helped scientists understand the long-term effects of microgravity. The dogs returned, their bodies weary but intact, their data invaluable. Across the ocean, the United States expanded its own program, turning to a wider array of species. Monkeys and chimpanzees continued to play a vital role, but other animals joined the journey: mice, rats, guinea pigs, and even cats. Each species offered unique insights, their biological systems revealing different aspects of space's impact on life. In 1963, France launched Félicette, a black and white cat chosen for her calm demeanor and responsiveness to training. She became the first feline in space, her mission brief but meaningful. Electrodes were implanted to monitor her brain activity, and she was launched aboard a Veronica G1 rocket. Félicette returned safely, her data contributing to neurological studies that would inform future human missions. Her story, though less known than Laker's or Ham's, remains a quiet testament to the diversity of life that touched the stars. Mice and rats, with their rapid reproductive cycles and well-understood biology, became staples of American and Soviet missions. They were used to study bone density, muscle atrophy, and the effects of radiation. Often housed in small compartments, these animals endured the stresses of launch and re-entry, their tiny bodies yielding vast amounts of data. Some missions involved breeding experiments, others focused on aging. The results helped scientists understand how space might affect long-term human habitation, guiding the design of future spacecraft and habitats. Guinea pigs, too, found their way into orbit. Their gentle nature and robust physiology made them ideal candidates for studying cardiovascular and immune responses. In 1961, the Soviet Union launched guinea pigs alongside dogs and reptiles, creating a miniature ecosystem in space. The animals interacted, adapted, and returned, their presence a symbol of life's resilience. As the missions grew more complex, so did the ethical considerations. Scientists began to question the necessity of certain experiments, weighing the value of data against the welfare of the animals. Protocols were refined, environments improved, and recovery procedures enhanced. The goal was no longer just survival, it was comfort, dignity, and respect. In this period, the role of animals in space shifted subtly. They were no longer just test subjects, they were ambassadors of biology, representatives of Earth's vast tapestry of life. Their presence in orbit reminded us that exploration is not a solitary endeavor, but a shared journey, one that includes all forms of life. The Cold War era also saw the emergence of collaborative missions, where animals were sent into space not just by superpowers, but by smaller nations seeking to contribute to the global understanding of space. Japan, China, and European countries began launching their own biological payloads, expanding the diversity of species and the scope of research. Frogs, fish, and insects joined the ranks, each chosen for specific traits, each offering new perspectives. These missions were quieter, less publicized, but deeply meaningful. They reflected a growing recognition that space belonged to all, and that the study of life beyond Earth was a universal endeavor. As we drift through this chapter, let us pause to honor the quiet courage of these creatures. They did not choose their path, but they walked it with grace. Their stories are not just scientific, they are emotional, philosophical, and deeply human. They remind us that progress is built on the backs of many, and that every step forward carries a responsibility to those who came before. In the silence of space, their presence was a whisper of Earth, a reminder of home. Their hearts beat in zero gravity, their eyes saw nothing but darkness, yet their lives illuminated the path ahead. And so, we continue our journey, moving gently into the realm of the unusual, where creatures not often associated with space found themselves floating among the stars. Tortoises, jellyfish, and even spiders, all played a role in this unfolding story. Let us explore their missions next, and discover the unexpected ways in which life adapts, survives, and teaches. As we continue our quiet journey through the stars, we now enter a chapter filled with wonder and surprise, where the boundaries of biology and imagination blur. In this part of the story, we meet creatures not often associated with space: tortoises, jellyfish, spiders, and more, each chosen for their unique traits, each sent aloft to answer questions only they could help resolve. Their missions were quieter, less publicized, but no less important. They remind us that life, in all its forms, holds secrets that can only be unlocked through exploration. Let us begin with the tortoise, a symbol of patience and endurance. In 1968, the Soviet Union launched Zond 5, a spacecraft carrying two-step tortoises, along with fruit flies, mealworms, and plants. The tortoises were selected for their resilience, their ability to survive long periods without food or water. Their journey took them around the moon and back, making them the first earthly creatures to complete a lunar flyby. Upon return, scientists found that the tortoises had lost weight but remained healthy, their slow metabolism proving advantageous in the harsh conditions of space. Their mission was a quiet triumph, a testament to the adaptability of life. In the years that followed, tortoises continued to play a role in space research, their calm nature and biological simplicity offering insights into long-duration flight. Their shells, like miniature spacecraft, protected them from the rigors of travel, and their presence in orbit became a symbol of life's quiet persistence. From the slow and steady tortoise, we move to the delicate and fluid jellyfish. In the 1990s, NASA began studying how microgravity affects the development of jellyfish, creatures whose movements are governed by gravity-sensitive structures called statoliths. Thousands of jellyfish polyps were sent to space aboard the Space Shuttle, where they reproduced and grew in orbit. Scientists observed that jellyfish born in space developed differently, their statoliths adapting to the absence of gravity. When returned to Earth, these jellyfish struggled to orient themselves, revealing how deeply gravity shapes life from its earliest stages. The jellyfish, floating gently in the darkness, became symbols of transformation, their translucent bodies reflecting the mysteries of adaptation. Their mission was not just scientific, it was poetic, a dance of biology and physics unfolding in silence. Spiders, too, found their way into orbit. In 1973, aboard Skylab, 2 European garden spiders were sent to study web building and microgravity. Scientists wondered whether spiders, whose webs rely on gravity for structure, could adapt their behavior in space. The results were astonishing. After a brief period of confusion, the spiders began spinning webs that were symmetrical and functional, despite the lack of gravitational cues. Their ability to adapt revealed the flexibility of instinct, the power of biology to respond to new environments. The spiders became quiet heroes, their webs floating like delicate sculptures in the stillness of the space station. Their story reminds us that even the smallest creatures carry within them the wisdom of survival. fish, too, joined the journey. Midlarka fish, zebrafish, and others were sent to space to study bone density, reproduction, and behavior. In microgravity, fish swam in loops, their sense of direction altered by the absence of up and down. Yet they adapted, finding new patterns, new rhythms. Their bones thinned, their muscles changed, and their movements became fluid expressions of life in a weightless world. These studies helped scientists understand how long-term spaceflight might affect human physiology, guiding the development of countermeasures and exercise protocols. Frogs, with their sensitive vestibular systems, were used to study balance and orientation. Their inner ears, similar to those of humans, responded dramatically to changes in gravity. In orbit, frogs performed swimming tests, their movements recorded and analyzed. The data revealed how gravity influences coordination, how the brain adapts to new sensory inputs. Frogs became quiet teachers, their bodies offering lessons in neuroscience and adaptation. Insects, too, played a role. Bees were sent to study pollination, ants to explore group behavior, and fruit flies to examine genetic changes. These missions were often small, tucked into corners of larger payloads, but they carried immense value. Insects reproduce quickly, mutate easily, and respond rapidly to environmental changes. Their presence in space allowed scientists to study evolution in real time, to observe how life responds to the unfamiliar. Bees built combs, ants explored tunnels, and flies adapted their genes, all in the silence of orbit. These creatures, often overlooked on Earth, became vital contributors to our understanding of biology in space. Even more unusual travelers joined the list. Tardigrades, also known as water bears, were sent to space for their incredible resilience. These microscopic animals can survive extreme temperatures, radiation, and even the vacuum of space. In 2007, tardigrades were exposed to open space aboard the European Space Agency's Photon M3 mission. Remarkably, many survived, some even reproducing after return. Their mission challenged our understanding of life's limits, suggesting that survival beyond Earth might be more common than we once believed. Tardigrades became symbols of possibility, their tiny bodies carrying the hope of interstellar biology. As we reflect on these unusual travelers, let us do so with quiet awe. Each one, no matter how small or strange, contributed to a tapestry of knowledge that continues to unfold. Their missions were not grand, their names not widely known, but their impact was profound. They remind us that life is diverse, adaptable, and endlessly surprising. In the stillness of space, their movements, their growth, their survival, all spoke to the resilience of biology, the power of evolution, and the beauty of exploration. These creatures did not seek the stars, but they touched them nonetheless. Their presence in orbit was a whisper of Earth, a reminder that life, in all its forms, is capable of wonder. And so, we continue our journey, moving gently into the modern era, where technology has advanced, ethics have evolved, and the role of animals in space has shifted once more. Let us explore how today's missions reflect a deeper understanding, a greater compassion, and a continued curiosity about life beyond our world. As we drift gently into the present, the stars above us remain unchanged, but the way we reach for them has evolved. Technology has grown more precise, more compassionate, and more aware of the delicate balance between exploration and ethics. The role of animals in space, once defined by necessity and urgency, has shifted toward refinement, care, and deeper understanding. In this modern era, the missions continue, but the intentions have matured. The International Space Station, orbiting quietly above our world, has become a sanctuary for science, a place where life is studied not just for survival, but for sustainability. Here, rodents, mice and rats, remain among the most frequent travelers. Their biology, so closely aligned with ours, offers insights into muscle atrophy, bone loss, immune response, and even mental health. But unlike the early days, these animals are housed in carefully designed habitats, monitored with advanced sensors, and cared for with protocols that prioritize their well-being. Their journeys are no longer one way. They return, and their data helps shape the future of long-duration human missions. In 2014, NASA launched the Rodent Research Program aboard the ISS, marking a new chapter in animal studies. These missions explored how microgravity affects healing, aging, and disease progression. The rodents lived in microgravity for weeks, their movements recorded, their health tracked. Upon return, scientists examined their tissues, their genes, their behavior. The goal was not just to understand space, but to improve life on Earth. These studies have led to breakthroughs in osteoporosis, muscle degeneration, and even cancer research. The animals, though silent, have become partners in progress. Alongside rodents, insects continue to play a vital role. Fruit flies, with their rapid life cycles and genetic simplicity, are used to study aging, immunity, and reproduction. In space, their genes express differently, their bodies respond uniquely. These changes help scientists understand how life adapts to stress, how cells repair themselves, and how evolution might unfold beyond Earth. Bees have also returned to orbit, their hives floating gently in microgravity. Their behavior, their communication, their ability to pollinate, all are observed with care. These missions are not just scientific, they are ecological, exploring how entire systems might function in space. Could we one day grow food in orbit, supported by bees and plants? These questions, once fanciful, are now part of serious research. Even aquatic life has found a place in modern missions. Zebrafish, small and transparent, are used to study cardiovascular health, neural development, and genetic expression. Their embryos, visible under microscopes, reveal the earliest stages of life in space. In orbit, they swim in circles, their bodies adapting to the absence of gravity. Their presence is quiet, but their contribution is vast. They help us understand how space affects the heart, the brain, and the very building blocks of life. Tardigrades, those resilient water bears, continue to fascinate scientists. In recent missions, they have been exposed to radiation, dehydration, and vacuum, surviving conditions that would destroy most life. Their genes are studied for clues to resistance, their cells examined for secrets of repair. Could their biology one day help protect astronauts from cosmic rays? Could their resilience be harnessed for medicine? These questions guide research, inspired by creatures no larger than a grain of sand. As technology advances, so too does our ethical awareness. The use of animals in space is now governed by strict protocols, reviewed by committees, and guided by principles of care. The goal is no longer just data, it is dignity. Scientists strive to minimize suffering, to ensure comfort, and to justify every mission with clear purpose. Alternatives are explored, simulations developed, and non-invasive methods prioritized. The conversation around ethics is ongoing, shaped by voices from science, philosophy, and public concern. In recent years, some agencies have reduced or even eliminated animal testing, relying instead on cell cultures, computer models, and human volunteers. These shifts reflect a growing respect for life, a recognition that exploration must be balanced with compassion. The legacy of past missions informs the present, reminding us of the sacrifices made, the lessons learned, and the responsibility we carry. Education plays a vital role in this evolution. Museums, documentaries, and classrooms now present the history of animals in space with nuance and care. Laika's story is told not just as a milestone, but as a moment of reflection. Ham's mission is remembered not just for its success, but for its complexity. These narratives invite empathy, understanding, and dialogue. They encourage us to ask not just what we can learn, but how we choose to learn it. In this modern era, animals in space are no longer symbols of conquest. They are symbols of collaboration. Their presence reminds us that life is interconnected, that every heartbeat matters, and that science must serve both knowledge and kindness. As we look to the future, we see missions that include plants, microbes, and even organoids, tiny models of human organs grown in labs. These innovations reduce the need for animal testing, offering new ways to study biology in space. The path forward is one of integration, where technology, ethics, and biology move together, gently and thoughtfully. And so, as we float through this chapter, let us pause to appreciate the quiet progress made. The animals of today's missions live in better conditions, receive better care, and contribute to research that honors their role. Their stories are not forgotten. They are woven into the fabric of exploration, guiding us toward a future where science and compassion walk hand in hand. In the silence of orbit, their presence is a whisper of Earth, a reminder of our shared journey. They teach us not just about space, but about ourselves, our values, our choices, and our capacity for empathy. Let us carry these lessons forward, as we prepare to reflect on the legacy of all who have traveled beyond the sky. In the final segment, we will gently gather these stories, consider what they have taught us, and look ahead to the stars with gratitude and care. As we continue to drift through the quiet corridors of memory, we find ourselves not in laboratories or launch pads, but in galleries, gardens, and stories. The animals who journeyed into space did more than contribute to science. They became symbols, woven into the fabric of culture, remembered not just for what they endured, but for what they represented. Their presence in orbit echoed far beyond the confines of their capsules, inspiring artists, writers, educators, and dreamers across generations. Laika, the small stray from Moscow, remains one of the most enduring figures in this narrative. Her image has appeared in murals, sculptures, children's books, and even music. She is remembered not just as the first dog in orbit, but as a symbol of innocence caught in the machinery of ambition. Her statue, quietly placed near the Russian Cosmonaut Training Center, shows her standing atop a rocket, gazing upward. It is not grand, but it is tender, a tribute to a life that touched the stars in the hearts of millions. In classrooms around the world, Laika's story is told with reverence and care, inviting students to reflect not only on science, but on ethics, empathy, and the cost of progress. Ham, the chimpanzee who pulled levers in orbit, has also found a place in public memory. His photographs, wide-eyed and expressive, are displayed in museums, reminding visitors of the intelligence and vulnerability that accompanied his mission. He is buried at the International Space Hall of Fame in New Mexico, his grave marked with flowers and quiet respect. His story is one of triumph and complexity, a reminder that even in the pursuit of knowledge, we must never lose sight of compassion. Thalassette, the first cat in space, was long forgotten, her name absent from memorials and textbooks. But in recent years, her legacy has been reclaimed. A successful crowdfunding campaign led to the creation of a bronze statue in her honor, placed at a university in France. It shows her sitting calmly, gazing upward, her posture serene. The inscription reads, "Thank you, Thalassette." It is a simple gesture, but one filled with meaning, a recognition of her contribution, her story, and her place in history. These memorials, scattered across the world, form a constellation of remembrance. They invite us to pause, to reflect, and to honor the lives that helped shape our understanding of space. They are not just tributes, they are lessons, reminders that exploration must be accompanied by reflection. In literature and film, animals in space have become metaphors for vulnerability, courage, and the unknown. Their stories are retold in documentaries, animated features, and speculative fiction. They appear as characters, as symbols, as echoes of real missions. These portrayals often blend fact and imagination, inviting audiences to engage emotionally, to see beyond the data and into the heart of the journey. In music, Laker's name has been sung in ballads, whispered in lyrics, and woven into melodies that speak of longing and loss. Artists use her story to explore themes of isolation, sacrifice, and the beauty of the cosmos. Her orbit becomes a metaphor for the human condition, a journey into the unknown, filled with hope and uncertainty. Educational programs now include discussions on the ethics of animal testing, using these missions as case studies. Students are encouraged to think critically, to ask questions, and to consider the balance between discovery and dignity. These conversations are vital, shaping the next generation of scientists, engineers, and thinkers. They ensure that the legacy of these animals is not just remembered, but learned from. In public exhibitions, interactive displays allow visitors to experience what these animals might have felt. Confined spaces, simulated launches, and the sounds of orbit. These experiences foster empathy, bridging the gap between observer and participant. They remind us that science is not abstract, it is lived, felt, and remembered. Even in digital spaces, their stories live on. Social media posts, online articles, and virtual museums share their images, their missions, and their impact. Communities form around these narratives, exchanging thoughts, emotions, and tributes. The internet becomes a place of collective memory, where the past is preserved and the future shaped. These cultural echoes matter. They ensure that the animals who ventured into space are not reduced to footnotes, but elevated to symbols of resilience and reflection. They remind us that every mission carries a story, and every story deserves to be told with care. As we float through this final chapter, let us carry these symbols with us. Let us remember the murals, the statues, the songs, and the stories. Let us honor the lives that touched the stars, not just for what they taught us, but for how they continue to inspire. Their legacy is not confined to science. It lives in art, in memory, and in the quiet spaces of the heart. And so, as we prepare to return to Earth, let us do so gently. Let us thank the animals who journeyed into the unknown, who carried our questions, our hopes, and our dreams. Let us remember them not just as pioneers, but as companions on the path to understanding. And now, as we float gently toward the end of our journey, the stars above us seem a little closer, a little more familiar. We have traveled through time in silence, through capsules and laboratories, through the quiet lives of creatures who touched the edge of space. Their stories, woven together like constellations, form a tapestry of courage, curiosity, and consequence. Each animal, from the tiniest fruit fly to the resilient tortoise, carried with it a question, a hope, a possibility. They were not astronauts in the traditional sense, but they were explorers nonetheless, venturing into the unknown so that we might one day follow. Their legacy is not just scientific, it is emotional, ethical, and deeply human. They remind us that progress is never without cost, that every step forward must be taken with care, and that the pursuit of knowledge must be guided by empathy. The data they provided shaped spacecraft, informed medicine, and revealed the resilience of life. But beyond the numbers and charts, they offered something more, a mirror to our own nature, a reflection of our choices, and a call to do better. Laker's orbit, Ham's Liverpool's, Feliset's quiet return, the jellyfish's floating dance, the spider's web in zero gravity, all these moments live on, not just in archives, but in the hearts of those who remember. They are stories told in classrooms, whispered in museums, and shared in quiet videos like this one. They are reminders that science is not just about discovery, it is about connection. As we look to the future, we see a new kind of exploration emerging. Missions are longer, destinations more distant, and the questions more complex. Yet the lessons of the past remain vital. We know now that life is adaptable, that biology bends and stretches in response to the cosmos. We know that ethics must evolve alongside technology, that care must accompany curiosity. And we know that every living being, no matter how small, deserves respect. The legacy of animals in space is not just about what they taught us, it's about how we choose to remember them. It's about honoring their role, acknowledging their sacrifice, and ensuring that future missions reflect the compassion we have learned. Their presence in orbit was a whisper of Earth, a heartbeat in the void, a reminder that life is precious, even in the vastness of space. In recent years, memorials have been created, stories retold, and names remembered. Laika has a statue in Moscow, Ham rests in peace at a museum. Faye Lissette's name has been reclaimed and honored. These gestures, though small, carry great meaning. They say, we remember. We care. We have learned, and that is the true legacy, not just the science, but the humanity. As we close this chapter, let us carry these stories with us, gently and thoughtfully. Let them guide our dreams, inform our choices, and inspire our compassion. Let them remind us that exploration is a shared journey, one that includes all forms of life, and one that must be pursued with kindness. Thank you for joining us on this quiet voyage through history and stars. Your presence here has been a gift, your attention a gentle light in the darkness. If you found peace in this story, if you felt wonder or reflection, we invite you to subscribe, to stay connected, and to continue exploring with us. Each video is crafted with care, designed to soothe, inform, and inspire. Your support helps us keep this space gentle, thoughtful, and welcoming. As you return to your day or drift into rest, may you carry with you the quiet courage of those who flew without wings, the resilience of life in orbit, and the soft wisdom of the stars. Until next time, be well, be kind, and keep dreaming.